Hi guys, this is a continuation of videos that I did on soldering and desoldering tools, and in that video we discussed these two hot tweezers. We're in a quest to try to find or make up a pair of hot tweezers that will cost me less than $100 that will actually work for me, and these two as they came did not do a sufficient job. This one over here suffered from several design limitations. Number one, it's only 44 watts, 22 watts on each side, which is kind of limited for some bigger components that you might want to desolder, SMD components. The heat is being produced in the elements in here, which are basically, it's like two separate little soldering irons, and the heat then has to travel all the way up these little slender tips here, which have limited conductivity because they're being so skinny. The tips were round, which means that it made it even harder to transfer the heat into the sides of the little SMD components, because being round, you know, they don't make a great contact. Also, it means that it is very hard to pick the component off, even if you melt the solder, to actually squeeze them together and to remove the components. Sometimes they would fall out, and if you squeeze too hard they would actually jump away and you have to try to find it somewhere on your bench. So the whole thing is, this didn't give me a very positive feeling, and also as you will see, as you have seen, I could not remove a component from a particular little PC board that I have, which is this one here. Now the story on this thing is, this is actually part of the Google's ill-fated Loon project. This little board was part of the system, and it was sent up into the troposphere or whatever it is, so it had to, I guess it had to deal with lots of temperature fluctuations, very cold and hot and so on, and I'm not sure if they use some special solder on this or whatever it is, but these components are almost impossible to remove, and certainly they could not be removed with any of these tweezers as they were. So this one here, these are actually mains powered, as you can see. These actually have a little bit more power than those, and they do seem to produce more heat. However, they came with these little bladed tips on them, which, and I'm not sure what kind of metal they are. They kind of were connected like that with these little screws here, and couple of problems with those things, that those little screws were hard to tighten up. They're just little crosshead screws, and you know, you would damage them if you tried to tighten them too much with a screwdriver. And these blades are very narrow, and had a similar problem to what these have. The heat would have to travel from here into those little narrow blades. They were better than these were in that respect, but still, and I don't know what kind of metal this is, but it was hard to get solder to stick to it. It would just get black, and that didn't work. So I've actually handmade some copper tips for it, as you can see here, and we will look at that in a minute. Now this thing is actually 100% better than it was. And this one actually now can remove components from this PCB, as we will see, because this is copper. I took a little copper, some copper tubing, and I took a hammer, and on the anvil I squashed it down and folded it over, drilled a hole in it, and I've used some proper hex head machine screws that I can really tighten up nice and tight. So these things are making a lot better contact with the hot part of these two elements, and also being copper, I was able to put a little bit of flux on there, and the solder just wicks onto it, and that makes a big difference to some of those SMD components. If you got some liquid solder that touches the sides of the component, the heat transfer is just 1,000 times better than it is just with a piece of metal. And so that's where these things fell down. So this now is actually, it was a test, but this is actually now a workable set. Although I would have preferred to have something like this where I can set the temperature. These things do work now, so I'm going to use these in cases where I've got some hard to remove components, so they will work for me. In any case, we were looking on the last video, we were looking on the internet, and we found these things on AliExpress, and they were different. They kind of looked interesting. These tips over here have a different shape, so I thought, well, they're only like $25, $24, $25. Let's get those and we'll try them out. So in typical fashion, I actually contacted the store that is selling them, Shenzhen Poly Mobile Phone Repair, something or other, and I asked them, I said, what is I noticed that the plug was compatible, at least in size, with an old soldering station that I have. It is this one here. Change cameras here. Okay, where's my mouse? There. I've got a, I don't know what kind of brand this is. I bought this some years ago, 937D soldering station. This particular one, I worked out that the socket on it is compatible with these in pin out at least. I opened it up and worked out where these pins go. Pin 1 and 2 on this particular one are actually the soldering iron is driven by AC. It's got a triac and it goes directly to the transformer. The transformer is rated at 26 volts, but I guess once you put a load on there it goes down to 24 volts. Pin 3 connects to the body of the soldering iron normally, and that's connected to the mains 120 volt mains earth circuit, and which means the tip is earthed, I guess. Pin 4 is actually the signal ground inside of the for the PCB, and pin 5 is actually the sense connector for the thermocouple or sensor that is normally inside of these soldering irons. But once I got this thing, I plugged it in and I found out that it was heating alright, but it was never turning off. The temperature sensor, the thermistor in here or something, obviously either wasn't working or was different. So then I took some measurements and I found out that on this soldering iron on the workstation, it was actually 95 ohms when it was cold and 160 ohms or thereabouts when it was up to temperature, which was kind of like 350 degrees or something like that I set it to. And then I measured it on these tweezers, and it was 1 ohm cold and 29 ohms when it was hot. I connected this thing to my thermocouple on my multimeter, so I was able to measure the temperature, so it was equivalent. So I made up this little extension here, a socket and a plug, and inside of this body here I put a 100 ohm resistor in series with the sense pin, and now it does turn on and off and keeps temperature, but of course it is a bit of a kludge, because as you can already see, if the station expects 160 ohms when it reaches the temperature of 350 degrees, and this one is going to be 29 degrees plus 100. It's going to be 130 degrees, 130 ohms, sorry, which is a little bit different, but also at a higher temperature they are probably not linear. So but in any case, at the temperature that I want these to work with a 100 ohm resistor, it seems to get to about 330 to 350 degrees, and I can nudge it up a little bit on the control on the workstation, and then it gets hotter. So I just set it to 350, and if it needs a bit more heat, I'll just increase it. So I got it working to that point, and we will see how these things work. These things too also have some limitations. They are not, as I'm squeezing these together, the two tips are supposed to meet each other, and if I squeeze gently they do, but if I put a little bit more pressure on it, you see they overlap each other, which is a bit of a problem when you're trying to sometimes when you're trying to heat the components, and it wiggles around. Also, that you can deal with, but the major problem with this is that the way that they are, if you try to get the components, these get in the way, and if there's a little component next to the component that you're trying to desolder or solder, they'd be hitting it and you can't get in there. And I've had that problem with some little components that are right next to other components. I'd have to put this on the on the microscope, but there's two little capacitors here. I cannot get those. I can get the ends of each one, but they are so close together in the middle that these can't get in there. So they also are not exactly usable in all instances either. What we really want is a set of tweezers that is shaped like these little tweezers. They should be like that from the top and squeeze together like that, and the sides of the tips should be flattish, and they should be able to connect to the component and be small enough to get into the smaller components. So what I found is that online, let me go and switch back to my screen. Well, I've been looking. I think I've showed some of that before. The only people that make decent hot tweezers right now, as far as I can tell, is the really expensive Weller, JBC, Hutco, and some others. And no matter what you do, you're going to be dealing with $1,000, $1,200 for Weller. And the Weller versions, there is one here actually for $840. I like the looks of those Weller tips. So let's have a look at these Weller tips here, tweezers I should say. I like the looks of. I think they are shorter and they have the right kind of pin-out. So let's have a look. See, they little skinny things, and they are exactly the shape that they should be. Little points pointing downwards and so on. But this is not in the price range that we're looking at. Just these little tweezers, and with a little stand width, and they want, and that's a cheaper price. It seems that this company here has a better price than like DigiKey and so on, that also sells this stuff, because they'll sell it for the full price, like $337. They're selling for $267. But then you have to buy a soldering station with it, and here they got one. Whoopee! It's on sale for $1,000 nearly. Um, it's so that's you know, we're still talking around $1,200 odd dollars. By the time you're done, it's probably shipping on it and stuff. Interestingly enough, Weller seems to have 12 volts instead of 24 volts. Not sure why they went to such a low voltage for those things. So that's the state of those. Interestingly, they also have some other tweezers, but these are not micro tweezers, they are bigger, and they say that larger SMT components. So I don't know what the full size of this thing is, but this is obviously not what we're looking for. They're also $300, and they connect to yet another type of workstation, a WRS workstation. So that workstation, as you showed you, it wouldn't even work with those. So interestingly enough, Hakko has a I wouldn't buy those, but I thought it was interesting because those are actually exactly the same as the tweezers I just showed you, was about $24 for at AliExpress. Exactly the same body. And also I've seen some workstations that include these tweezers that have both these kind of tips with those blades on there, which I don't think is a good thing, which I've displayed for the other ones. And they come with also with the tips that are on there right now with the little narrow tips. So that's kind of interesting how they are selling these $25 tweezers for $200. Hakko has a hot tweezer set here for $310 basically. I don't know why they bought 99 cents. Well, they think I'm stupid or something. $310. Which I am not 100% sure. It is a little bit unclear on those pictures exactly if they would be what we're looking for. They seem to be kind of straight, and I like those bent ones, as I said, that the Weller ones have. So here you have a Hakko station and a soldering iron and tweezers for $800 at iFixit. Again, it's out of the range. These were already looked at. Now here is a Weller station with a little soldering iron and the tweezers that look desirable. Some reason they thrown in a pair of pliers, but they want $840 for it, and it seems to me that this is probably, as again, it's a test equipment depot. It seems to be that is probably the best price you can get these for, if that's what you're going to be if you're willing to spend that much money. So that's kind of the state of affairs. And on I've looked at Banggood and AliExpress and Amazon, everywhere else, and I have not been able to find any other tweezers in these. These are everywhere. Some people are selling them for $40, some people selling them for $60, some people selling them for $80. You have to be careful with these sellers. These things sell anywhere from $20 to $40, and these things, there's another version of these with a different number, but they seem to be identical. But they're like $25. It's all I found that looks kind of semi-promising. So this is what I have found out for the record. Let me go to this here. So first of all, I tried those for the record, and we will go and should play that on this video here. So I got these things set to like 400 degrees according to their display. When I was doing this, I put a little bit of flux on there, And later on I tried it by putting some solder on there as well. It was just no good. That's that little tricky circuit board, of course. Could not get them off, no matter how hard I tried, how long I waited. So that was a abject failure. Then I went and tried those other ones with still with the blades connected, which was the mains powered ones. Also same thing, just it wouldn't budge no matter how hard I tried. And then I tried these ones here, the ones I got recently from AliExpress, those Iohu ones or whatever they're called. Same deal, couldn't get that off either. And as you can see there, when you squeeze it a little bit too hard, those tips get out of alignment, so you've got to be careful, but still you see they snap off. Also failure. I applied some solder to it over here and tried it again, but the solder would melt not nicely, but it wasn't actually coming off either. And finally I decided to use some hot air on them, and then finally with the hot air I was able to get it off. I had to set the hot air to like 430 degrees C. Use quite a lot of heat there. So I decided to add a little bit more flux. Anyway, to make a long story short, let's fast forward a little bit there. See, it came off. So that was the only success that I had at that time. Okay, so then as I said earlier, I made up these homemade tips on that other tweezers that I have, and I made them up out of pieces of copper tubing, which I flattened with a hammer and folded it over, drilled a hole in them, put some little machine screws in there, and they're not pretty to look at, but here we're going to I'm discussing them here in this video, and let's see if I can make this full screen. It'll be better. Let's fast forward a little bit. So here I'm demonstrating how, because they're copper, I'm still waiting for them to heat up, so because they're copper, the solder wicks to them nicely, which is really helpful too. So here we're going to there's actually a little component here. I actually already removed them with those things and put them back again, but I'm just showing. You see it comes off, unlike these other tweezers. And now we're going to try some other components that haven't come off yet, and as you can see, it still takes quite a lot of effort on that particular PC board to get those to come off. I just put a little bit more solder on the tips there, and you can fast forward a little bit there. Okay, boom, see it finally came off, and you can put it back again as well. You see I soldered it back. the one next to it. Of course, it already got a bit preheated. Okay, so that was a success. For good measure, let's try another one. And these are actually larger than the ones that I tried before with the other tweezers, so they would even take more heat. I'm actually putting a little bit more solder onto the tips there to make sure that they have a good contact. There it goes. So let's fast forward a bit over here. So here I'm going to be trying them on a different circuit board. Now you notice that the difference, and where the other tweezers, they will work there as well. These components have next to the pads are wider than the component, and there's solder on there. So these ones you can get off with the other tweezers quite well as also. And then I found that the IOU tweezers, if there is no components right next to it, you can actually get in there. They are the most effective to get to pick up the little components. As you can see on this one here, now because of the solder on it actually sticks to the tips, which is a pain in the neck if you're trying to solder them back, because you put them on there and then you lift the tweezers and it lifts the component back off again. But the other ones don't do that. So I guess the moral of the story is that I got no tweezers that are perfect, because I'm not willing to spend $1,200 for a soldering station with a pair of tweezers that look a little bit more promising. See the little components even sticking to the tweezers. And I'm demonstrating that to how hard it is to put the components back. There we go. See, I soldered one back again. It is doable. Okay. Anything else there of interest? Oh, this is yet another circuit board. These are very, very tiny capacitors, and of course the tips are made a little bit larger, and I was going to see how hard it is to do those tiny ones. Yeah, they come off pretty straight away, but those other tweezers would have worked here as well. So solder them back again. Little capacitor. See, those type of things that are just connected to signal lines and so on, they just come off just really easy. And you can hold on to them with these kind of tweezers, not with the other ones. And you can just put them back on like that. So they do have a purpose if you've got to remove some components and put them. Yeah. This one potentially has a little bit of a ground plane on it, but still it comes off, and I could put it back in the other spot, for instance. See, it's they definitely are, for this they are definitely a lot better than the than those other ones are. They've got sufficient heat for that and everything. None of these are exactly good for all purposes. Of course, we have different, like if I got difficult components that have to be removed, like on that particular PCB, that it makes it really hard. I've now got a set here that I've made up that that has good heat transfer, and they will work. Of course, I can always use hot air. These two over here, these are actually more pleasant to use if the tips don't get in the way. These are the most pleasant to use and the easiest to pick up the components with and to solder them back. And these over here, in some instances I can still use it, I guess, and but I suspect I'll be using these and those for my most of my desoldering tips, and these will probably languish in the drawer. Another thing that I want to try now is I'm just curious if I can take this PCB over here and stick it in my infrared rework station and actually heat the whole board up, which it has a heater underneath, and then will these tweezers then work? That will be another interesting little test. So I'm going to do that next, and you will see the results of that. Okay, I've got this problematic little PC board here connected to my infrared rework station. I guess you can't see it, but you will in a moment. So I've got these tweezers heated up here, and just verify that this particular component here if it is removable or not. No, it's not budging. So let's turn on the heat from below. Okay, the PCB has actually reached 100 degrees C. So let's have a look at what stage we might be able to let's try this one. Let's see. 127 degrees. 122 to 127 degrees the PCB is now. Any of those want to come off? Even the little one? But the tweezer set to 350 degrees. Let's make them go a little bit higher. 365. Okay, well that helps that little component to come off. What about the big one? No. Now let's add some infrared light. Okay. I set it for 250. Closer. I need to wear these special glasses now that came with it. Oh yes, look at that. Way to go, man. Look at that. They're just falling off. See what I mean with these tweezers? You squeeze with them and the little component jumps away. Okay, so we've learned something here, haven't we? Okay, turn them all off. Okay, so it seems to me that using these tweezers, these are the lowest powered ones that I have. In order to use those on a difficult PCB like that one, if you use that rework station, maybe I can put it in view. Hang on for a sec, you can see. So I've got it set on this infrared rework station, and so I guess what we've learned is that if you've got a difficult PCB, then you can still use these kind of tweezers and those kind of tweezers, provided that you heat the board up from underneath. But even that wasn't quite enough for these. But this particular infrared workstation with the infrared light beaming down on from the top set at 250 degrees. In fact, I'm not even sure if you needed the tweezers, but you could set the temperature a little bit lower, and then the tweezers would heat just enough, add just enough heat to remove those components from the PCB, so you can rework it that way. And the board is still quite hot. Alright, so I guess that's all I've got. Maybe we're doing something wrong, or you want me to try something else, leave some comment in the comments there to discuss this. I'd be most interested. As you know, I've got back into electronics after a hiatus for like, I don't know, 30 years or so, having been involved in software development instead, and now I'm trying to get back into it, and I have to get all these new equipment in order to be able to work with the latest electronics with SMD components and all that kind of stuff. So that's what I'm actually doing here. I'm learning what's available and what works and what doesn't work. So I'd love to hear some comments. Until next time, I'm going to be evaluating some of the transistor testers and things that I have, which is kind of interesting too. One of them is able to put the curves of the transistors and so on the PC, and you can actually look at those. Anyway, until next time.